Hello, I'm Francisco Boer, Managing Partner at the Innovatie. Welcome to this presentation. This time, we'll talk about simeg. Simeg is an integrated electricity and gas markets simulator. We'll cover why it is important to use a simulator and what we can expect about it. Please feel free to contact us anytime if you have questions related to this presentation. You can reach us out at simeg@theinnovatie.com. But before we start, I want to introduce the Innovatie, the organization that supports simeg. The Innovatie is a team made up of data scientists and engineers with more than 15 years working on multi-industry solutions with strong requirements on statistical modeling and mathematical optimization. We developed and implemented solutions across multiple industries, mainly financial services, energy, transportation, and manufacturing. Throughout our history, we developed several products. For the energy industry, we have simeg. Before we dive into the guts of simeg, we'll try to respond to the question that many of you probably have in mind. What is it used for? The agents of the energy market face different kinds of problems. To solve these problems, it is necessary to quantify variables and relations between them. Unfortunately, there are a lot of problems that bear no relation to the past. Therefore, we are not able to extrapolate. In some cases, those relationships are far from being linear. Let's see some examples. What would be the gas availability impact for Buenos Aires industries if a new gas pipeline is built between Vaca Muerta and Buenos Aires with a certain capacity? And in the gas for power plants? This is a problem that doesn't have a significant relationship with the present nor the past. Its resolution must consider as a minimum the new hypothetical gas network topology and the electrical and daily gas dispatches. What would be the expected amount of gas to be exported given a certain stock capacity of it? This problem also has no relation with the present nor the past. It's a daily scale problem that also needs to consider the eventual use of power plants gas, every type of demand variability on each network section, the gas pipeline's network topology, and its daily flows. How could I calculate the dispatch distribution probabilities for a given thermal power plant for the years to come? To answer this question, we must assess the impact of future projects from both markets. We also need to consider electricity demand evolution and its relationship with temperatures. To have a proper estimation of such probabilities, among other things, we must consider multiple climatic scenarios. Under what conditions could we expect power outages next summer? In this case, we have to consider relevant dimensions from all previous problems, because it depends on power plants availability, gas availability, and demand, which in turn depends on climatic conditions. Given all these considerations, we arrive to the following conclusions. Bottlenecks are only evident on a daily scale. We cannot use weekly or monthly averages. The level of dependence between both markets inhibit any sort of independent analysis. We need to assess a significant amount of climatic scenarios. And finally, we could not extrapolate with historical data. The best way to have an accurate representation of the system as a whole is to perform proper simulations. So, what is simeg? simeg is a simulation software that models the integrated daily electrical and gas dispatches. The power plant's gas competes with that of exports and industrial consumption on the joint dispatch. The LNG with Bolivia's imports and local spot. Hydraulic generation with the thermal one. simeg performs the joint dispatch of electricity and gas, considering the main attributes of both systems. This dispatch is performed for every day within the simulation horizon. Those time frames are simulated as many times as the number of temperatures and contributions available. As a result, we'll obtain a faithful representation of the variables and its occurrence probabilities. simeg's engine was developed using C++, which is one of the most efficient programming languages available. It is therefore many orders of magnitude faster than the available alternatives for a given analyst, like Excel or Python. As a consequence, simeg enables fast complex analysis with ease and concentrates efforts on what really matters. It could also be used as a calculation library. simeg's persistence layer is supported by SQL Server, which enables both the management of huge volumes of data and the integration with business intelligence corporate toolkits. Now that we know what simeg is, let's see some specific use cases. With regard to the electricity market, simeg enables forecasting for prices and costs, energy and power dispatched, non-supplied energy, line flows, fuel consumption, imports and exports. All of these could be performed with the required level of detail and its respective occurrence probabilities. simeg also enables the impact assessment of hypothetical scenarios. What would happen within the market if some new hydraulic, thermal, or renewable power plant are built? And new transportation lines? Where is it optimal to build a new power plant? Now we can have a better understanding of how simeg could help us solve these problems from the electricity market. Let's take a look now at the gas market. In this case, we'll be interested in a different set of variables, but always with the same precision level and occurrence probability. Some use cases are gas trunk lines flows, LNG and pipeline imports and exports, industrial supply by day and rate zone, and these are just some of the forecasts that we could perform using simeg. Another possible outcomes are the answers to questions such as, what would happen with the gas market if we were able to stock large quantities of it, or have liquefaction facilities? And higher production in Vaca Muerta or new gas pipelines? What about new imports and exports by pipelines or LNG? Now, let's deep dive into the main variables and restrictions represented in the mathematical model. The main electricity market variables are the generated energies transmitted through the network lines. All these variables are represented for each of the 3 hourly bands for every simulated day. The generated energy is detailed by shaft and fuel type. Its detailed interaction with the gas market is represented through the power plant gas consumption with all its cost components. The pipeline's flows are in accordance with the first and second Kirchhoff laws with quadratic losses. simeg also represents the weekly management of hydraulic dispatch and liquid fuels stocks management with all their costs by origin. Now we'll specify the gas market's main variables. Daily injection by basin, divisible by take or pay and spot. Imports and exports by pipeline. LNG with its respective stock, regasification capacity, and the replenishment volume of LNG carriers. Trunk lines flows that operate with maximum capacity, consumed gas, and line pack variations. Daily demand represented by user type and rate zone with its respective temperature, seasonalities, and growth sensibilities. Industrial demand by area with the associated priority steps. Power plant contracts with its respective outage days are represented. simeg has more than 200 parameterized reports. For instance, you can query monthly and daily balances by area for both gas and electricity. The data model is flexible enough in order to be modified with ease in response to changing market conditions. From the graphical interface, you can query all reports that are grouped together by topic and time interval. The results are displayed both in tabular and graphical form. All of them are exportable to different formats. They are also queryable from other tools like Excel and Jupyter, among others. Given all these attributes, simeg is a fast and flexible simulation software for a proper integrated gas and electrical markets analysis. I hope this video has been useful for you. Thank you.